Hi, welcome back. Today we are going to discuss the MCQ set 2 of satellite communication. During an Earth eclipse, a satellite mainly depends on which power source? Option A, solar panels. Option B, battery power. Option C, fuel cells. Option D, nuclear generators. We know that during the time of eclipse, no sunlight will be there. So there will be no generation of electric power, which means that the solar panels will be inactive during the time of solar eclipse. So during the time of solar eclipse, the satellite mainly depends on the battery power. So the answer is option B, battery power. Now, next question. The main source of power for satellites is option A, solar arrays. Option B, nuclear reactors. Option C, fuel cells. Option D, thermoelectric units. In the previous session, we discussed that during the time of Earth eclipse, the satellite will be relying on battery power. But the main source of power for the satellite is the solar arrays. So the answer is option A. The station keeping ensures option A, thermal balance. Option B, orbit maintenance. Option C, antenna gain. Option D, power regulation. We know that due to the gravitational pull and also the solar radiation pressure and other atmospheric disturbances, it will cause the satellite to be pushed away from its assigned orbital slot. So, the satellites is requiring a periodic adjustment to maintain itself in the orbital position. This particular thing is known as station keeping. So, the station keeping ensures the orbital maintenance. So, the answer is option B. Next question. The escape velocity of Earth is roughly option A 7.9, option B 5, option C 11.2, option D 1.2. We know that the escape velocity is the minimum speed an object must have to completely escape a planet's gravitational pull without any further engine thrust. And here the escape velocity is option C, that is 11.2. Next question. What is the primary function of attitude control system in a satellite? Option A, power regulation. Option B, thermal control. Option C, station keeping. Option D, control of satellite orientation. We know that attitude control system, that is ACS, it is responsible for maintaining and adjusting the orientation of a satellite in space. It actually ensures the antennas to be point towards the correct position to the earth, then solar panels to face towards the sun, etc. So here the correct option is the attitude control system in a satellite ensures the orientation control of satellite orientation, that is option D. Now from the options we can see that the power regulation, it is usually done with the help of power subsystem in the satellite. Then thermal control is usually done with the thermal control subsystem in the satellite. Station keeping, it is usually done by the orbital control subsystem. So these are the other subsystems functions. So what is the primary function of ACS? That is attitude control subsystem in satellite. It is the control of satellite orientation. What does TT&C stand for in a satellite system? Option A, time tracking and control. Option B, tracking, telemetry and control. Option C, transmitting, tracking and communication. Option D, telemetry, time and communication. We know that TT&C stands for telemetry, tracking and control subsystem in a satellite. So the answer is option B. Next, the transmitter-receiver combination in the satellite is known as dash. Option A, relay. Option B, repeater. Option C, transponder. Option D, duplexer. We know that the transmitter and receiver combination in a satellite is known as the transponder. Actually, what is a transponder? What is the function that it is doing? In a satellite, this transponder will receive the uplink signal from the earth station. Then the transponder will amplify it, then changes its frequency, and then it will retransmit it to the earth on the downlink. So The transmitter, it will be performing both the transmitter and the receiver function, hence it is known as the transponder. Next question. Why are VHF, UHF and microwave signals being used in satellite communication? Option A, more bandwidth. Option B, more spectrum space. Option C, are not diffracted by the ionosphere. Option D, economically viable. We know that the answer is they are not diffracted by the atmosphere. Answer is option C. We know that the VHF, UHF and microwave signals, they are usually the high frequency signals. They can pass through the ionosphere with the minimal reflection and diffraction, making them suitable for and reliable for satellite communication. If we are using the low frequency signals, they will be reflected or absorbed by the ionosphere, which would disrupt the communication. So, we are usually using the VHF and UHF and microwave signals for satellite communication. The answer is option C. Next question. A transponder is a satellite equipment which, option A, receives a signal from Earth station and amplifies. Option B, changes the frequency of the received signal. Option C, retransmit the received signal. Option D, does all of the above mentioned functions. We know that a transponder, it is known as it does what functions it receives and also retransmit the signal, and also it amplifies the signal, and also it does the frequency translation. So we can say that the answer is option D, it does all of the above mentioned functions. So answer is option D. Now next question. A geosynchronous satellite. Option A has the same period as that of the Earth. Option B has a circular orbit. Option C rotates in the equatorial plane. Option D has all of the above. We know that geosynchronous satellite, they are having the same period as that of the Earth, that is 24 hours, and also it is having a circular orbit, and also it is rotates in an equatorial plane. So the answer is option D, that is has all of the above. Next question. The geosynchronous communication satellites travel around the Earth in circular orbits with a forward speed of about -km per hour. The answer is 11,200. Option A. For satellite communication, the analog signals may be converted into digital form with the help of option A, modem, option B, transponder, option C, codec, option D, compounder. The answer is option C, codec. Codec is actually a coder decoder, which is actually used to convert the analog signals to digital form for the transmission. So, for satellite communication, the analog signal is converted to digital form is with the help of codec. That is option C. Next is the satellite engine uses dash jet propulsion, B ion propulsion system, option C liquid fuel, option D solar jet. The answer is ion propulsion system. That is option B. That is the modern satellites mostly uses ion propulsion systems for the station keeping and also for orbit adjustments, etc. So the satellite engines are mainly using ion propulsion systems. Now we can move on to the next question. Earth area covered by a satellite radio beam is known as option A, beam width, option B, bandwidth, option C, footprint, option D, zone. The answer is option C.